Hello, friends. This week we are going to be discussing the last two sections of Chapter 40, which is an introduction to quantum physics. In this review, we are going to discuss sections 7 and 8 of Chapter 40, the double slit experiment and the uncertainty principle. So for the first section, we're going to discuss what's known as the central mystery of quantum mechanics, or the double slit experiment. Wave particle duality is an accepted concept that has been proven by experimental results. A way to prove the concept of an electron's wave particle duality is through an experiment where electrons are sent through a double slit, also known as the double slit experiment. In this experiment, you have a monochromatic source of light that's pointed at a screen with two slits. As the beam of light hits the first sheet, it squeezes through the two slits, resulting in each slit acting as two separate light sources. After passing through the slits, the light diffracts, or spreads out, creating interference between the two separate light sources. On the second screen, we end up with a pattern that kind of looks like multiple rows of light. And if we measure the angles at which the maximum intensity of electrons arrives at the second screen, we find that they are described by the equation d sine theta equals m times lambda, where d is the distance between the slits, m is the order number, and lambda is the wavelength. For the last section, we're going to discuss the uncertainty principle. In 1927, Werner Heisenberg introduced the notion that it's fundamentally impossible to make simultaneous measurements of a particle's position and momentum with infinite accuracy. And therefore, Heisenberg's uncertainty principle states that if a measurement of the position of a particle is made with uncertainty delta x, and a simultaneous measurement of its x component of momentum is made with uncertainty delta p sub x, and the product of the two uncertainties can never be smaller than Planck's constant over 2. At the time, Heisenberg made sure to point out that these uncertainties didn't stem from inaccuracies in the actual measuring process or the instruments used, but rather that they came from the quantum structure of matter. The mathematical form of the uncertainty principle states that the product of the uncertainties in position and momentum is always larger than some minimum value. Another form factor of the uncertainty principle can be viewed here as delta E times delta T is greater than or equal to Planck's constant over 2, where E is frequency and T is time. And that concludes it for the review of section 7 and 8 in chapter 40, where we went over the double slit experiment as well as the uncertainty principle. And as always, if you enjoyed the content, please drop a like down below and hit that subscribe button to never miss one of my future videos. Thanks again, and see you next time.